Hello everyone, this is Kitish here. In this video, I'm going to go through the AQA Physics Paper 2 Higher Tier from 2025. Question number 2 is on the topic of forces. A student investigated how the force applied to a spring affects the length of the spring. So this is to do with the Hooke's law experiment, and it's actually a required practical, I think. Figure 1 shows the apparatus used. So you can see the spring with the mass hanging at the bottom and a ruler being held up. Not straight, but slanted, okay. And resort stand. What is the independent variable in this investigation? This is the force applied. You could also say the weight of the masses. Or you could say the mass hung from the spring. Describe one risk of harm in this investigation and a safety precaution to reduce the risk. Risk of harm, mainly one thing, if you have the stand could tip over because of the weight and hit the student, or the masses could fall on the floor and hit the legs. And safety precaution would be to clamp the stand. So stand could tip over and hit the student, and safety precaution is to clamp base of stand to the desk. The student measured the length of the spring using the arrangement shown in figure 1. Give 2 ways the student could have changed the arrangement to improve the accuracy of the measurement. Well, we saw that the ruler wasn't actually straight, so hold up the ruler straight and make sure it's actually clamped, and there's no marker to help read this the end of the spring. So you call this fiduciary markers. So you could use a small toothpick or a piece of paper, sellotape to the end of it, so again it actually acts like a marker, right? And the ruler doesn't look like that it has subdivisions between those values, which means you could use a ruler with a higher resolution. So any two of this will be fine. Ensure the ruler is vertical. Clamp the ruler close to the spring. Attach a pointer to the bottom of the spring, or use a ruler with a better resolution. The student recorded accurate values for the length of the spring as the masses on the spring increased. The student calculated the force applied to the spring by each mass. So you can see that the force is, as the force increases, the length of the spring also increases, but it's not at 0, okay? Why does the line on the graph not pass through the origin? That's mainly because at 0 newtons, they're saying the length of the spring is 3 centimeters. That would be mainly because they didn't take away. They are not calculating the extension of the spring. They're just basically measuring the length of the spring with the forces. So with 0 force, it was 3 centimeters. So the answer is the initial, or original you could say, length of the spring is not 0. So length of the spring in centimeters as a clarification, the student did not calculate the extension of the spring. Above 6 Newton, the line on figure 2 curves upwards. Explain why. Now, above 6 newtons, up to 6 newtons, a straight line. If it's curving above, that means with an additional 1 Newton, it's actually getting longer than it initially should. So even up to 7 Newtons, it's got longer by 2.5 centimeters. From 7 to 8, it actually got longer by 3.5 centimeters. So that means it's not behaving elastically. So the spring is inelastically deformed. So the extension is no longer proportional to the force applied. Use the physics equation to answer the question. Which equation links extension, force, and spring constant? So force equals extension multiplied by the spring constant. So first one is correct. When the force on the spring is 4 Newton, the extension of the spring is 0.064 meters. Calculate the spring constant of the spring. So force equals the extension multiplied by the spring constant. 4 equals 0.064 multiplied by the spring constant. Spring constant equals 4 divided by 0.064. That gives you 62.5 Newton per meter. 62.5. That brings us to the end of question number 2, and I will see you in question number 3.